Welcome to Exploring the Variable Site Part 5, Full Page Hotspots and Determining Quadrants. Today we're going to address how we can make our chart fully interactive like the variable site. It doesn't matter where my mouse is on the page, that stroke is going to follow it, and the appropriate stage that I'm over is going to be highlighted. Now this effect is a little bit more complex than you may think, and with that being said, we're going to work on a much simpler file here where we're just going to have 4 simple divs that we're going to work on highlighting regardless of where our mouse is on the page. If I'm down below, if I'm over them, or if I'm up top, it's not going to matter. And today we're just going to start by determining which quadrant we're actually in, and then we'll work on the highlighting, making it responsive, and implementing with our project. Let's get going. So as always, we're going to be working in the standalone very simple file so that we can focus strictly on the pertinent JavaScript that we need. The HTML is dead simple with a singular main class here that contains div 0 through 3. Main has a darker background than its child divs. What I want to point out is that when I resize the browser window, we're going to maintain consistent 100 pixel padding on the left and right, but the interior divs are going to be stretching using Flexbox, okay? So we have this sort of flexible center, but hard-coded paddings on the side. Now what we want to attempt today is really just to take my mouse cursor position and map it between wherever this left edge of the div 0 is and the right edge of div 3. So in order to do that, I'm going to need to know the width of the browser window here and the width of this padding that I have on the sides. Now in the CSS, for now, I've hard-coded the padding on main to be 100 on the left and 100 on the right. So I know for a fact that's always going to be 100 pixels. Now we're going to start doing some basic math in our JavaScript here, and I've set up a few variables to help us get started. Window width is going to be referencing document.body.clientWidth, which gives us the exact width between the left edge of the document all the way to where the scroll bar begins. If we had used window.innerWidth, that would have gone all the way to the right, including the scroll bar width, which we do not want. Now our min-x value of 100 represents the left padding, okay? The distance between 0 and 100 right here. To determine where this point is, which is our max x, we're going to take the full window width and subtract the min-x value, which is now 100. And we'll get that using window width minus min-x. Now I've gone ahead and I'm logging out all 3 values so that you can see at this window size exactly the values we'll be working with. So right now you'll see that our window width is 953, our min-x is 100, and our max-x is 853, which as you should expect is 100 pixels less than our window width. So now I want to move forward and make it so that as we're moving our mouse around, we can track specifically when it's between our min-x and our max-x. And to do that, we're going to use GSAP's Observer. And according to the GSAP website, Observer is a super flexible, unified way to sense meaningful events across all devices without wrestling with all the implementation details. Down here is an awesome video for you to watch, and one of the more important features is that it is going to debounce our events so that we don't have to worry about them firing too often, as typical mouse move events do. Further on down the page, they have this wonderful example where I can just flick my scroll wheel on my mouse, and that's going to get me to the next screen. I can flick up and go to the previous screen. That's all driven by Observer and not ScrollTrigger. If you want to load from the CDN, they have a link available in the Quick Start Guide right here, but I'll show you how to pull it into CodePen easily. So back in our demo, I'm going to go to my JavaScript settings, and I'm just going to type in Observer. I'll click on GSAP Observer, Hit save and close, and we're ready to go. To use Observer, I'm just going to paste in this boilerplate code here, where we're going to call the observer.create method. By passing in window as the target, it specifies we're going to be listening for events on the window. We'll be listening for pointer and touch events, and we're going to set up an onMove callback, which has access to the observer using self inside that function. And inside that onMove callback, I'm going to just log out self.x. And now when I move my mouse around, you'll see that we are getting those x values logged out in the console. Now I only want to be logging them out when my mouse is between my min-x and my max-x values. So to do that, I'm going to use GSAP's clamp method. Now I don't want to put all my code right here in this onMove. So I'm going to put everything regarding my heavy lifting and number conversion in this handle pointer function up here. So let me just change this out to handle pointer and pass in self.x. Now in my handle pointer function, which will get that x value passed in, I'm going to create a new x value and set it equal to gsaputils.clamp. I'm going to pass in the minimum value in the range, the maximum, and then the value that I want clamped to that range, which is my x value. Once I've figured out what new x is, I'm going to go ahead and log out the new value. With that in place, when I move my mouse around now, watch what happens when I'm on the left here. You'll see that clamped equals 100, okay? I can't get a value between 0 and 100 because 100 is the minimum value that I have clamped to. However, when I go past 100, you'll see now that the values are going to increase. And they're going to increase all the way till I get to my max x value of 853. And now when I'm over to the right here, I don't get any values bigger than 853, even though my mouse is beyond 853. That's exactly what clamped is for. So now that I can get a value between my min-x and max-x, I want to further normalize that value between 0 and 1 so that I can break it up easily into fourths, or I should say quadrants. So we're going to go ahead over here and tap into GSAP's normalize utility by updating our new x value and setting it equal to gsap.utils.normalize. And my minimum value again is going to be min-x. The max value in my range is going to be max-x. And the value I want to normalize is going to be new x. And now we'll also log out that new x value. So now when I move my mouse, you'll see I get my clamped value and then my normalized value. Where I've stopped here, the position was clamped to 149.71 blah blah blah, but if we map that to a value between 0 and 1, you'll see we get 0.06. If I go right to the edge here where we're going to hopefully clamp to somewhere very close to 100, you'll see that my normalized value is 0. So when I'm at the min-x, I get normalized to 0. And when I go all the way out to my max-x, let's try to get it right on 853, you'll see that I am now normalized to 1. So now that we can move our mouse anywhere on the page and get a value between 0 and 1, we just need to break that value up into quarters or fourths. And basically what I want to do is if I'm somewhere here under the 0 and my normalized value is between 0 and 0.25, I want to know that I'm in section 0. If I'm under this next div here and I'm normalized somewhere between 0.25 and 0.5, I want to be able to generate the number 1. Now, although that may seem easy for some of you, it wasn't for me. So I headed on over to good old ChatGPT and very politely I asked, "Hi, I need a JavaScript function that takes in a value between 0 and 1. The function needs to tell me which quadrant the value falls in such that a value between 0 and 0.25 would be quadrant 0. A value between 0.25 and 0.5 would be quadrant 1, and so on." Well, ChatGPT replied with this function called getQuadrant, which takes in a value. It makes sure it's between 0 and 1. If not, it will give us this little error of value must be between 0 and 1. I know my value is going to be between 0 and 1, by the way. And then it ran the value through a number of conditions. If the value is less than 0.25, return this. If it's less than 0.5, return 1, and so on and so forth. And then it also gave me this output down here showing how different values would correspond to various output quadrants. And although this is all very nice, I wanted something a little bit more mathematically advanced. I don't want to write all these conditions if maybe I had 10 quadrants, all right? It would become too much. And then very politely I added, that is great. Can you do it without all those conditional checks? Sure! You can simplify the function by using a mathematical approach. Here's how you can do it without conditional checks. And so the meat of this is that it takes my value, multiplies it by 4, and runs it through math.floor, which brings it down to the nearest integer. And again, it shows me these various examples of different numbers outputting to different quadrants. That looks great. And it even gives a more verbose explanation of how it all works. And just make a little mental note that it says 0.75 all the way less than and equal to 1 will return 3. We'll come back to that. But for now, this is really just the meat that I need. I need to take this little equation here, copy it out, and let's hop back into our file. And then now I'm going to do one more calculation. I'm going to say new x equals what we got from ChatGPT here. I'm not going to return right now. And I want to make sure that value is my existing new x value. And once I've done this final calculation, let's go ahead and console.log quadrant equals new x. And now I'm expecting some real fireworks here. Let's go over here, and as I roll around, notice that I'm under the 0, and you will see that my quadrant equals 0 as the last log. When I move on over to boop 1, I get quadrant equals 1 here. When I go to 2, quadrant equals 2, and lastly, quadrant equals 3. We're taking a clamped x value of 640, we're normalizing it to 0.839, and then we are multiplying that number by 4 and flooring it to get 3. If I shoot my mouse over here above the 0, I get quadrant 0. Same thing as I'm moving back and forth. When I'm to the left of the 0, I still get 0. Okay, that's important. But watch what happens when I move all the way to 3, and now I'm going to move to the right of quadrant 3, and I get quadrant equals 4. That is no good. ChatGPT, I want numbers when my normalized value equals 1, meaning I'm all the way to the right of my clamped range. I want quadrant to still be 3 because there's no quadrant 4 or div 4 that I'm going to be able to highlight, okay? So, as frustrated as I was, I very politely went back to ChatGPT, and let me just scroll down here, and I said, hey buddy, if the value equals 1, the returned value is now 4. When value is equal to 1, it needs to return 3. Wonderful humility, ChatGPT responds, good catch. To fix this, we can cap the value at 0.999 before multiplying, ensuring that a value of 1 falls into the third quadrant, which is 3. Here is the updated function. And what they're doing here is they're checking if value equals 1, then we're going to return 0.999 times 4. Or else we'll just do our normal multiplication of value times 4. So again, I will take this little snippet of code here, I'll copy it out, return back to my file, and update this bit of the code right here by pasting in what ChatGPT gave me, and we're going to change value to new x in both places. And now, when I'm in this sort of to the right of quadrant 3, I get quadrant equals 3 down at the bottom. So I can be anywhere on the page. I'm over 2, and the last console log gives me quadrant equals 2. And so in the next lesson, I'm going to show you how we're going to take that quadrant value and highlight the appropriate divs when I'm rolling over them or anywhere on the page. So I know this was a lot today, but hopefully you can go through it line by line, read out the logs, and understand what all this does. And if you're new to coding, I just want to demystify a little bit of this line of code here, which may scare some beginners. And basically it's a shorthand for writing this conditional statement right here. It checks to see if new x equals 1, then it's going to floor 0.99 times 4. Or else it's just going to take new x and multiply it by 4. And we can write that by putting the new x equals 1 condition. And if true, whatever happens after the question mark here is what will get floored. Or else anything after the colon will occur. So just a little something to know, and I hope this helps. Come back next time and we'll work on highlighting the divs and deactivating them when we roll across anywhere on our page. See you in the next lesson.